Find the derivative of f of t equals t squared plus 1 over the square root of t minus 1, then evaluate f prime of 2. So f of t here is the quotient of two different functions. We have a t squared plus 1 divided by the square root of t minus 1. Let's rewrite that radical root in the denominator as a fractional exponent, so its first power and second root are 1/2 power overall. So we can use the power rule when we take the derivative of that. But overall we have a quotient of two different functions, so we're going to make use of the quotient rule. The derivative, f prime of t, will be the derivative of the numerator, which is a 2t, and the 1 will be a 0 for the derivative, times the denominator left alone, minus the numerator left alone, times the derivative of the denominator. Now, it's a power rule for the denominator, so we'll bring down the 1/2, we'll subtract 1 from it, I will call that 2/2, and then multiply by the derivative of the inside, which is just a 1 here, to complete the chain rule. And then that entire thing is over the denominator squared. So in the numerator we have a 2t times a t minus 1 to the 1/2 minus everything's multiplied. That 1 doesn't change anything that's at the end. We have a 1/2 here. I'm going to put it to the front. This 1, as I mentioned, doesn't change anything. So we just have a 1/2. We have a t squared plus 1. And we have a t minus 1 that'll be to the 1 minus 2, negative 1/2. All of this will be divided by t minus 1 to the 1/2, then to the 2. Now when you raise and raise again, you actually can multiply those exponents there. So that'll be t minus 1 to the 2/2. Now back in the numerator, we have a 2t times a t minus 1 to the 1/2. The second term has a negative exponent. It's right here. Now that can move to the denominator. There's already a 2 in the denominator in the 1/2 right there. It'll move down there with the 2. The numerator will be left with a 1 and a t squared plus 1, which is just a t squared plus 1. So really we just have minus what will be a t squared plus 1 over a 2 times t minus 1 to the what will now be a positive 1/2 power. All of this divided by t minus 1 to the 2 over 2, which is 1, so we can just call that t minus 1. The next step, since we have a fraction in the numerator right here, we're going to need to get a common denominator between the two terms, so I'm going to need to put that over that same denominator. Now, that first term does not have a denominator just yet. It's a 2t times a t minus 1 to the 1/2. So the common denominator is the denominator under the other expression, so that will be the denominator 2t minus 1 to the 1/2. So we're going to multiply this by 2t minus 1 to the 1/2 over itself, a form of 1, in such a way to produce the common denominator so that we can combine it with this other term that already has that denominator. So I'll just rewrite that other term again. And then all of this is over t minus 1. Now, multiplying these numerators, we have these multiplying. I will move this 2 with this 2t. That will be 2 times 2, 4t. And then the t minus 1 to the 1/2 can multiply the other t minus 1 to the 1/2. And if you multiply these together with each other, you add their exponents. 1/2 plus 1/2 is 1. So what we'll have overall is a 4t times a t minus 1. And then notice we're subtracting this other fraction, so that means you're subtracting that entire numerator. So minus t squared plus 1 all over, it's now over the common denominator, which is 2 times t minus 1 to the 1/2. And then the entire thing is over t minus 1. So this equals 2. The next thing I'm going to do, I'm going to distribute the 4t into here and the negative into here. That will give us a 4t squared minus 4t, and then distribute the negative t squared minus 1 all over 2 times t minus 1 to the 1/2, and then that entire thing over t minus 1. Now if we combine like terms together in the numerator, I have a 4t squared and I have a minus t squared. So that will be 3t squared. I have a minus 4t and a minus 1. All of that is over 2 times t minus 1 to the 1/2, and then that entire fraction is over a t minus 1. Now since I have a fraction in the numerator, I'm going to turn the denominator into a fraction by putting it over a 1. I'm going to reciprocate and multiply. So f prime of t will now be 3t squared minus 4t minus 1 over 2 times t minus 1 to the 1/2, and then times a 1 over t minus 1 when I reciprocate it. Now I'm multiplying these t minus 1's that are in the denominator, in which case you add their exponents. Now the exponent of the t minus 1 here is a 1, but what we can do is call it a 2/2, so it has a common denominator, so we can add those exponents. Now up in the numerator we're going to multiply these with each other, but this is multiplying a 1, so it'll just be 3t squared minus 4t minus 1. And in the denominator we will have 2 times t minus 1, add the exponents, 1 plus 2, 3 over 2. It'll be to the 3/2 power. There's the simplified version of the derivative f prime of t. The next thing to do is evaluate f prime of 2. F prime of 2 means to plug a 2 in for each of the t's. And we will have 3 times 2 squared minus 4 times 2 minus 1 over 2 times 2 minus 1 to the 3/2 power. 2 squared is 4, so 3 times 4, minus 4 times 2, which is a -8, and then minus 1, over 2 times 2 minus 1 is 1, that will be to the 3/2 power. 3 times 4 is 12, a -8 and a minus 1 will make a -9 altogether. And then a 2 times 1 to the 3/2. Now that means the square root of 1, which is a 1, and then you will cube that result. 12 minus 9 is the 3. And we'll have 2 times 1 cubed, of course, is a 1. And we end up with 3 over 2 times 1, which is a 2. 3 over 2.